Greetings. This is a quick overview that's going to help with becoming a Martian math teacher. You may not have heard of Martian math, and that's why I'm giving you this quick orientation. It's about 6 minutes, and I'm going to show you some resources that you can use to get oriented, so you understand. I'm going to spend about half a minute just looking at this page. This is Wiki Educator. If you don't know about it and you're a teacher, you should. It's a pretty interesting place. You can put your own stuff there for free. I've got this thing called Digital Mathematics Heuristics for Teachers that is going to put Martian math in the context of four different kinds of math. Casino math is like probability, statistics, risk management, the kind of things. It goes all the way back in time. This is not a new invention. Speaking of time, Neolithic math is sort of the timeline pointing backwards into the past. So we study math in an historic context, and Martian math is the opposite, it's going into the future. So between Neolithic and Martian, you get a sense of a timeline. And then between casino and supermarket math, you get a sense of commerce and industry, risk management, and then, distributing inventory. Once you've taken your risks and made your investments, how do you get it out to the people? And that's the supermarket part of it. So it's designed to be somewhat comprehensive with these categories. You may not want to use those particular names, but that's what we've got going on this particular web page. And you'll find a lot more to read. I'm scrolling down so you can see where there's more. Sorry about the dog in the background. That's Sarah. Sarah's my very old dog. You may not hear her, but so back to the storyboard. Um, Again, you're going to get a lot more out of it if you go to Reed College Saturday Academy class. It was at Reed College. I'm saying some years ago during the summer. It was actually middle and high school aged kids that were in the class through Saturday Academy. And so there's going to be a link to that so you can go through and look at the different things. And Mars is either we go to Mars, we being humans, or the Martians come here in the different stories. Now, of course, we don't believe in Martians if we ever did, but nevertheless, for teaching purposes, it's good to have another civilization coming from outer space, ETs or whatever. And that's where these storyboard pictures come in. You, as a teacher, can use this story. It's not a copy protected story, it's a folk tale. It's out there for anybody to use. And the idea is the Martians on the left and the Earthlings on the right want to build a dam together, hydroelectric power dam, and that's a chasm. I call it bridging the chasm, is what the picture is showing. It's kind of a pun on C.P. Snow's essay about the chasm between sciences and the humanities, but it doesn't have to be taken that way. And the dinosaur, never mind, that was on the whiteboard when I gave this talk. Anyway, the Martians and the Earthlings have different ideas. The radius of a circle r times 2 would be the diameter. And on the right, you've got, see, the diameter is what the edges of the tetrahedron on the left are going to be d, and the edges of the cube on the right are going to be r. It might be kind of confusing at first. That's not the same volume. Over here's r on the cube, and over on the left is d, diameter of the sphere. So that's a relationship, and that's what we start with, you might say, as an interesting entree into two ways of showing third powering, the cubed way and the tetrahedron way. This is a toy that you might get a hold of. So many interpretations can be made of this story, and I'm looking forward to animations of the kind that I'm actually not quite able to do. Like here, we've got a giant tetrahedron anchored with these lines, and it's, I guess, storing water up to level 3, which is 27 in their system, 3 to the third power, because a tetrahedron is the Martian model of third powering as opposed to a cube. You saw an airplane over there for scale. That's really big. Again, I'm sort of reviewing here the basics. You'll have modules that you want to fold up that you can make these different shapes that are going to have different volumes than you're used to. It's kind of like Kepler and having a polyhedra inside of other polyhedra. It's not unfamiliar mathematics, a lot of Euler. You're going to find a lot of overlap with stuff you're already trying to learn or teach. Filling polyhedra with beans, building out of kits, all sorts of toys to enhance your understanding. So do think about becoming a Martian math teacher and teaching this material yourself. Thank you.